previously we learned how to set up triangle proportions using similarity statements. And you'll notice that none of these pairs of triangles have similarity statements. Well, then we additionally learned that there are theorems that prove that triangles are similar. And once we've proven that they are similar, we can set up proportions. And so what we want to look at these problems and see how can I use triangle similarity proofs or postulates and theorems to show me how to mark up this triangle so that I can match up the pieces and set up their proportions. So if you look at these triangles, the first thing you might notice is these sides are parallel. You might also notice these vertical angles, and it doesn't matter which one you notice, okay? You're going to end up using and marking them all. So let's look here. I've got these two parallel lines, and I've got that transversal. That means if lines are parallel, then alternate interior angles are congruent. I can also do that same thing using those same parallel lines and this transversal. That gives me that these two alternate interior angles are congruent. And then I already know vertical angles. And so all you needed was 2 of the 3. That means that these two triangles are similar by angle. Now, the reason that that's important is because now this is going to tell me how to set them up. So here's what you want to do. I like to pull all of my numbers over to one side. It doesn't matter whether you move the numbers, the 10, the 15, and the 20 over to the small triangle, or the X, the Y, and the 6 over to the big triangle. It doesn't matter. I'm going to move them over to the big triangle just because I have more work or more room over there to write. So let's look here. So first you want to look right here. This 10, the side that is labeled 10, on one end we have 1 mark and on the other end we have 2 marks. And so we look at our little triangle and we find the one that has the same marks. There's 1 and 2. That means that the 6 is going to match up with the 10. Now, if we look at the 15, BC, here's 15, it has 1 mark and 3 marks. And so we want to go find the piece that matches it. Well, that's Y. It has 1 mark and 3 marks on its end. So 15 is going to match with Y, which then leaves our 20, which has 2 and 3 on either end, to match with X, which has 2 and 3 on either end. And so what that does is that gives me all of my ratios so that I can set up my proportions. So I want to solve for X, so I'm going to start with 20 over X. That's the ratio that has the X in it. And then the 15 over Y doesn't do me any good. It's true that 20 over X is equal to 15 over Y, but that's not useful. So I'm going to use the 10 over 6. So if I multiply that 10 over 6, now I can do my cross multiplication. So I get 20 times 6 is 120. Remember that we set this up, 120 is equal to 10x. Divide both sides by 10 and you get 12. And you can do a quick double check. Make sure that x is shorter than the piece that it came from. So the side that matched up with it was 20 and it is smaller, right? 12 is smaller. And so, in fact, it's 3/5 as big. If you do 6 over 10, you get 3/5, and so it is 3/5 as big. That's one way you can do it. And so then we want to find our y. So we can set up 15 over y is equal to 10 over 6. Now, let me kind of back up for just a second. I mentioned something, that scale factor. So I had 10 over 6. That reduces to 5 over 3. Notice that I go from the big triangle to the small triangle, so technically then, well, not technically, but it is my scale factor to go from the left triangle to the right triangle would be 3/5. That means I can take everything on my left side triangle and multiply it by 3/5. So let's just do a quick check. 10 times 3/5 is 6, which matches up. 20 times 3/5 is 12, which matches up now, and then 15 times 3/5 is 9. Well, let's just do a quick check here with my cross multiplication. 15 times 6 is 90, and then divide that by 10, and you get that y is 9. So you can do it either way. If using scale factors makes more sense to you, you don't have to use proportions, but you do have to recognize what you're supposed to multiply. Notice how they kind of crisscross, that the green and the purple, they crisscross, because that's going to be important when we look at this next problem. So let's look at question 2. I've already given you that r is congruent to t. So I look and I get any other information I have. First thing I see is vertical angles. That's really, you're going to get information about the angles from vertical angles and from parallel lines. That's our primary source of information, of giving you information without straight out telling you information. Then automatically, I know by the third angles theorem that Q and U have to be equal to each other. If two angles of one triangle are congruent to two angles of another, then the third has to be congruent. So now we're going to match it up. So let's pay attention to how our pieces are marked. That's why it is extremely important that you go ahead and you mark the pictures, you mark the angles on your picture. So RQ, which is marked with X, notice that on one end it has 1 mark and on the other end it has 3. So we go over here and we find the same piece. I'm going to match the X with the 24. So I'm going to come over here and put the 24 on that side just so I don't have to think about it again later. Then we've got, let's do RS next. No particular reason. RS has 1 on one side and 2 on the other. And so I want to match that up with 18 because it has the same markings. So it's going to be 21 and 18, which leaves 12 to go with Y. I'm going to go ahead and color code it so that we can see the difference between the two problems that we just did. Take a look at this. Notice how in problem 1, your 15 and your y, your x and your 20, they crisscross with each other. But when you did 2, you used 21 and 18 together and 12 and y together. Now, you go in and you set up your proportions. Again, you could find your scale factor with your 21 and 18. But I think it's easy, too, to set up proportions. X over 24 is equal to 21 over 18. So we have 24 times 21. Divide that by 18, and you get that X is 28, which makes sense. It does have to be bigger than 24. And then Y, it's 12 over Y is equal to 21 over 18. 12 times 18, and then divide that by 21, and you get that that is 10.3. Now, I know it's a little disconcerting. It's 10.2857 ... more. It's disconcerting when you get decimals because we don't often get decimals in math class, but they do exist. And so always double check your answer when you get a decimal and then be confident in what you did and know that you did it right. And it is correct. It is 10.3. Okay, this next problem, we need to know how to match it up. You won't ever be given a similarity problem that you can't solve. If I ask you for X, you'll be able to find it. Notice that I have my 35-degree angle. I have my two sides. So these two triangles are similar by side angle side. So I know how they're going to match up. It's easy to see that the 30 goes with the 20. The 18 goes with the 12. And then the 3x minus 6 matches up with the x plus 6. Don't let that scare you. We'll deal with that in just a second. So don't try to solve it all the way to the end right now. Go ahead and set it up so that you can see it. Now, you may look at this and go, well, which one do you use? It doesn't matter which one you use. You might choose 30 over 20 simply because it has those zeros. And in fact, just as a side note, you could simplify that to get 3 over 2. And so we could use just 3 over 2, and in fact, I'm going to do that because it's easier than 30 over 20. You don't have to write so many zeros. We have 3x minus 6 over x plus 6. Remember, when you cross multiply, it's everything times everything. So it's 3 times x plus 6. Don't forget, you don't have to write this step, but it might be helpful. In fact, I think it's helpful if you go ahead and put parentheses around there to remind yourself to do the whole thing. And then it's 2 times 3x minus 6. So I'm going to write down what I want to do, and then I'm actually going to do it so that I remember to do my distribution. So I have 3 times x is 3x, 3 times 6 is 18, 2 times 3x is 6x, and 2 times negative 6 is minus 12. Now we're just going to do our algebra. You've got variables on both sides. So we need to subtract 3x from both sides to move that over, and we need to add 12 to both sides to move that over. We end up with 30 is equal to 3x. Divide both sides by 3 so that you can isolate that variable, and you get that x is equal to 10. Okay? So we get x is equal to 10. So that means that this side is 24 and this side is 16. We can plug them back in and see. And you can see that 24 over 16 has that same ratio as 18 over 12 and 30 over 20. They reduce to 3 over 2. Now, in number 4, the easiest way to do this, if you're in advanced, then there's another way to do it. I'll explain it. But when you look at this problem, it may be easier for you sometimes to separate it into two big triangles, right? We have a little triangle and a big triangle. We have x, 6, and y, and then we need this whole side. Okay, so we need this whole piece. If I knew what x was, I would add it to 18. So I'm going to put x plus 18, and then this whole side here is this whole piece, 6 plus 24, that's 30. And then the bottom is 35. And so now I can set up all of my pieces. I can match them up. X plus 18 is going to match with x. Again, these match because these are our alternate, or our corresponding angles. And then we also have that overlap, right? So we've got this situation so we can tell how everything matches up. These are a little more straightforward as to how they match up. So now we just sit and we set up our proportions. X plus 18 over x is equal to 30 over 6. And 35 over y is equal to 30 over 6. Be careful again when you cross multiply here. You have to do 6 times x and 6 times 18. You get 30x. So now you have 108 is equal to 24x. You get that x is 4.5. Don't often get those decimals, but we know we set it up right. And then 35 times 6, and then divide that by 30. And you get that that y is 7. Now, if you're in advanced, you might notice that these two sides have been split by DE. So this is the side splitter theorem, okay? And so you could have set up x over 18. X was the whole side of the little triangle. 18 is the part of the little triangle, of the big triangle, and you can set that equal to the whole side of the little triangle is equal to the part of the big triangle. So you've got whole over part equals whole over part. Now, that's allowed, but you have to be very careful because when you set it up, you still have to do, if you do y over 35, okay, y is the whole bottom, 35 is the whole bottom, 6 is the whole side, which means you have to use the whole side. So where you're going to get tripped up is right here with that 30. You're going to try to do the y over 35 the same way that you did the 6 over 24, and it isn't going to work because y and 35, the DE and the BC, those were not your split sides, so they're not proportional in that same way as AE and EC are. And so you have to be really careful. If you're going to use the side splitter theorem, it only applies to the sides that actually got split. But you don't ever have to use the side splitter theorem. You can just set up your parts how they match with the angle-angle theorem and use whole side over whole side. And so